Right, so I guess I'll go ahead and get started. I'll keep this nice and short. I'm filling in for the guy who didn't even respond and decided that he's not speaking, but didn't bother to inform us. So I'm filling in for that guy, but I've done this talk before, so hopefully I can bring some value to this, add some value to this particular group of people. And what I wanted to do was, I want to talk about this Azure service called Cosmos DB. So how many of you over here have heard of Azure Cosmos DB? How many of you have used it? Okay, okay, sure, okay. So I won't even ask my next question, which was going to be, how many of you have used the multiple models of Cosmos DB? So I won't ask that. So anyway, the talk, I changed the title from introduction to saying that everything you wanted to know about Cosmos DB, but are afraid to ask. So this is your chance. So you probably heard a lot of hype about Cosmos DB, and a lot of it is good. I'm definitely bullish on Cosmos DB, so I like a bunch of different features that Cosmos DB offers. So obviously, and I go around giving talks on this, so I'm a huge fan, but I also wanted to approach it from the perspective that I'm also a consultant. So part of my job is to make sure that I offer the best possible solution to the client, so they're not stuck with some kind of white elephant to speak of. So as part of that, I try to evaluate the upsides and downsides and suggest solutions accordingly. So I wanted to approach this talk from this perspective. Other things I do, I'm the president of the Orlando.NET user group, organizer of Orlando Code Camp. So if you haven't signed up for any of those, I encourage this audience to do that, and please show up at our events because we have really good events. And if you ever need to get in touch with me, those are my contacts. I work for Nebier Tech, which is a local Azure and DevOps consulting shop, and best way to reach me is probably Twitter. Like, people DM me on Twitter all the time. It's fast. Or you can email me. If you contact me on LinkedIn, please make sure you mention that you're not a recruiter. And these are some resources that I've used to develop these slides. I will upload these slides to our GitHub repo and add that link on our meetup page for this event. So you should be able to get it from there. So these are a few things I want to touch on. I want to talk about polyglot data persistence. I want to talk about value versus cost. So Cosmos DB is not the cheapest service on the planet, for sure. When people, I've done it myself. Like, I was coding, I created a Cosmos instance. I showed people in the talk, during the talk, how to crank it up, and then I left it cranked up for a month. So then the next month, the bill came, and that was not good. So, but Cosmos DB is expensive, but that's why I want to talk about what value it brings and why does it justify, at what point does it justify the cost. So we'll talk about some basics, and I'll quickly walk through some starting samples. I will also upload the code samples. Right now I'll only display it on slide because I didn't have the time to create the whole coding section of code. So again, so this is really hard to see, but I can read it out. So this is Azure Cosmos DB is a NoSQL database as a service that's offered by Microsoft Azure. which means that you can find Cosmos DB only on Microsoft Azure. You cannot find it on AWS. So how do I deploy Cosmos DB to AWS and Google? It's not going to happen. You cannot deploy it on on-premises, sorry. So the on-prem or on-premises. You cannot deploy it on-premises unless you have Azure Stack, which the guy was talking about this morning. Unless you have that running on premises, you cannot deploy Cosmos DB on premises, and definitely not to AWS or Google. So what does it's a NoSQL database as a service that enables you to distribute your data globally, and you can actually go to the Azure portal when you have a Cosmos instance, and you can say that I want my data to reside in North America, Europe, India, and Brazil. And within a few minutes, it's all up and running and fully compliant with the SLAs. In fact, it starts storing data right away. So as soon as it gets created, it starts storing data. But to get the full performance, it takes a few minutes. But it'll work. So same elastic scale-out, guaranteed low latencies. We'll talk about that, but when you read to a Cosmos DB instance when you write to a Cosmos DB instance or read from one, it takes single-digit milliseconds for that to happen. So that is pretty fast if you're familiar with cloud speeds. Has 5 consistency models. NoSQL realm usually offers 2, like eventually consistent or strong consistent, right? And this offers 5, and we'll talk about that in a few minutes. And it offers a bunch of SLAs, which is service level agreements. Service level agreements. So when someone says I'm 99.99%, we have 99.99% uptime, that's a part of an SLA. And you can store data in different formats. You can store data as key value databases, column family databases, document databases, which is JSON documents, and that's the one I'll show an example, and graph databases. And we'll talk about all of these in a few minutes. And if I get close to 3:45, just remind me that I'm running late. And before I would go into this, I spend my time talking about the features of Cosmos DB. I figured I'd put it on one slide. Actually, I did not do this, someone else did it. I just copied it from that guy. So Cosmos DB, multi-master rights. So let's say you have your data distributed to 2 instances, one in North America and one in West Europe. You can say that instead of saying that I'll write to North America only, and from there it goes to West Europe, which means people in Europe, when they try to do the writes, they have to write to North America, and that's not an optimal experience. Also, I think Chris earlier showed someone writing from Australia to North America, and that takes, I think it takes 32 milliseconds or something if you calculate. That's the fastest that it can travel, and we want to do single-digit milliseconds. So you can spin up an instance in Australia, and you can allow them to write, and they both will sync up. But when you do that, that means that you cannot have a strongly consistent database. It's anything but strongly consistent. We have a bunch of different options here. It does automated backups. Because you have multiple instances, you can easily handle failovers. So acid, can someone tell me what acid is?
It's
not a drug, just
it's an acronym.
yeah, it's an acronym. Yeah, well, it's an acronym. Yeah. Atomicity, consistency, isolation, durability, which are the tenets of relational databases. Those are not available in non-relational NoSQL databases. But with Cosmos, you can do ACID type operations within within a partition. and what is a partition, we'll talk about that. Change feed, this is to me the number one feature of Cosmos DB that enables a lot of things. So it's kind of like a RSS feed. If you are familiar with RSS feeds, when someone publishes to a blog, it pushes out saying that there's a new blog post. It's similar to that. When someone writes to a database, it pushes out all the changes that were done to the database, and you can use these changes to do further operations. So you can also create or copy that exact data to a different database using change feed. So it's a really good method of asynchronously performing operations post storage of data. Encryption, so it does encryption at rest and transit, so really secure operations. Geofencing, you can store in different instances, and you can tell your SDK that I don't want any clients outside of this geographical instance to talk to my Cosmos, to talk to anything but this particular data center. So that's geofencing. It supports geospatial data, which means that if you're doing mapping type data, mapping type calculation like distance between 2 points or circle, you can do that. It supports link style querying. You have a local emulator. The local emulator, please keep in mind, it currently only supports two document databases, which supports something called the SQL API or the core API, which used to be called Document DB, which Amazon now has a Document DB, so it's not confusing at all, by the way. So it supports the SQL API, which is a JSON document store, and it supports Mongo API. So you can actually you can take a system that writes to a Mongo database, and you can point it to Cosmos, and in most cases it will work. However, I'm working on cases that it doesn't work. So there's Troy right there laughing at me because I cannot do that on projects that I work on. So I know nothing about what it does with ODBC, so I will not talk about that. I don't try ODBC with Cosmos DB, but apparently it works. So there you go, ODBC. So if you delete data, it does a recycle bin type. You can keep deleted data for up to 30 days. Again, I've never used that feature, but it's on the feature one. This is really important, security. So people will always ask when you're creating a system, like if you're doing work for enterprises or government, they will ask about, they're really strict about security, so it does support certain standards. So if you're doing HIPAA compliant data, yes, you can store it on Cosmos DB. Serverless binding, so if you're running Azure functions, you can simply hook it up in the config file, and you can read and write and listen to change feeds using your Azure functions. So it works really well with that. And Cosmos DB also has stored procedures, triggers, and user-defined functions. These run within the context of a container, and they are basically JavaScript code that runs on the Cosmos server. So you create JavaScript code. Let's say you write a JavaScript Hello World program. You update it, you upload it to the server as a stored proc and execute it, and it runs. That's pretty useless, but I'm just giving an example. Cosmos DB supports multiple models of data store, and we talked about that. So previously it used to be called Document DB, now it's called SQL. You'll also hear the word core. That's all the same. It's a JSON document storage. Similarly, a Mongo. Table is Azure Table Storage, which is basically like a bunch of flat tables that you can. It is now run by the Cosmos DB team, so you can still use your old Azure Table Storage, but Cosmos has the Cosmos team has a premier instance which you can hit with the API. Graph, you can store graph databases using the Gremlin engine. and even supports Cassandra storage, which is a column family. Uh, the data structure is called ARS, atom, record, sequence, and atom is basically basic data types like string, I think it does Boolean and integer. I don't exactly remember what all it covers, but so that is an atom. A record can be an atom, or it can contain a collection of atoms, or it can also have subrecords. And a sequence can have atoms, records, and subsequences. So that's the general storage, and everything is JSON, stored as a JSON. And obviously, this makes it polyglot.
Good question. I use Azure tables now, so you're saying that Cosmo DB has Azure's table, or they just group them on the same team, or you can use Azure table within Cosmo DB, or they're still separate? Explain what you mean by
Okay. Yeah, good question. So the question is, and I'm repeating it so I understand it correctly, but also for the stream. So the question is that you're using Azure table currently, and you're using it as part of the storage infrastructure, and
Correct.
you want to know if that no longer exists, or it'll go away, or if
I
it's
just saw it there. What does
okay.
explain
So
that a little further?
so yes, so basically that Azure table, which you are using under storage, it's been taken over by the Cosmos team, if I understand that correctly. If I understand Microsoft structure correctly. But you can continue using it under Azure table storage, and it will be supported for a long time, if not forever, until a meteor strikes us or something. But there's also Cosmos team offers a premium version of that, and you can access that premium version only as an API on using the Cosmos engine.
The
So-
benefit is premium, meaning just lower latency.
Yes, yeah.
Larger
So
storage.
yeah. Okay. So what are the benefits of that? So the benefits of that are it will offer the same type of SLAs that Cosmos offers. So you can do single-digit millisecond latencies for your read and write operations, and you can do the global distribution the same way that you can do other Cosmos services. Simply click on a map and distribute it. Right now, because it's under Azure table storage, it uses that model. Like I think it's GRS and zone redundancy and all of that. But this one you can simply click and distribute on a different day. So you get all of the benefits which you get from the Cosmos platform, but the price is more. So
That's why I use
normally
Azure.
the use case I've seen for Azure table storage is you dump a whole bunch of things and it's dirt cheap. I think if you read Troy Hunt's blog on how he does his service, Have I Been Pawned? He talks about how he uses Azure table storage to store data and do it at dirt cheap at like $5 a month or something for billions of records. This will not be the case if you move over, but you get other advantages. So again, it's the cloud. You have to do some kind of trade-off. How you choose
That's
to.
why I use Azure Table, because Azure SQL, well, I didn't need relational, I need NoSQL. Cosmo DB, it's fatter, it's more expensive, and that was just a nice little middle ground. It was inexpensive, NoSQL, it fit perfectly.
Right. So Cosmos DB has different types of data storage. And table just happens to be one of them. So it just depends on your use case. So if you want to do it for dirt cheap, you don't care about the performance or global distribution, you should probably continue using the older service.
Is it that bad of a cert? I mean, what?
It's not that bad. This one is that much better in terms of performance. Yeah, I wouldn't say. I mean, people have used that for nearly a decade now, and it's been pretty good. So, yeah, nothing against that. It's just if you need superior performance, global distribution, this is how. So the SLAs are defined as latency, throughput, consistency, availability, and the fine print is that everything, when we say SLA, it applies for within a region. And if you have a system that has, Cosmos DB that's 99.59 SLAs, and you have Azure SQL that has 4 nines SLAs, but you have a virtual machine running that is only 99% available, it's always the lowest. So, or even lower than that. I think you start multiplying, and it actually gets to 97% SLA or something. So just keep that in mind. You cannot say because I have one component that's far better than the others, my SLA is superior. That's not how it works. The SLA always depends on the lowest metric. Latency, again, that's the just latency is basically how long does it take to do reads and writes. So from the time you start, operation starts to end, that's your latency. Like you said, Cosmos DB is single-digit millisecond. I think it's gotten faster. This might actually be outdated. They have brought down all of this to single digits. And how they do it is it's a lock-free database, so it's not a relational database like SQL Server, so there's no locking mechanisms. And then they use SSDs to store data and super fast connections. And then you have throughput. What is throughput? Again, it's like the amount of items passing through a particular system in and out is the throughput. So if you're reading and writing data, the combination of that is the throughput, which is different than a bandwidth. So again, bandwidth versus throughput is a huge thing in networking. And what we're talking about is the read and write operations. The combination of that is the throughput. And we'll talk about that in a minute. Right here. So throughput in Cosmos DB is measured as a resource unit, or RU. And this is a slightly, when you configure Cosmos DB, it starts at minimum 400 RUs. What the heck is that? No one knows, right? If you're using it for the first time. What it is it's the amount of throughput you can perform. If you do a read operation for a 1 kilobyte document in 1 second, that's 1 RU. So if you do 400 kilobytes per second, it's 400 RUs. So that's what it is. But keep in mind that that's the basic. But in reality, when you create, read and query the documents, you will see that the throughput is not, for a 1 kilobyte document, could be as high as 15 RUs depending on what type of consistency you have configured for the system. So this could vary. So for instance, when you write to a system and it's strongly consistent, it could be as high as 15 RUs. But if you make the consistency lower, like if you make it eventually consistent, that number goes down. So that's another way of saving on costs in Cosmos DB. And you can actually write queries that look like SQL queries. So that's an example. If you configure a system with 1,000 RUs, so that's about $60 a month. That's the sample session. Consistency. So this is another interesting concept of Cosmos DB. Most systems offer, most NoSQL databases either offer strong or eventual. So what Cosmos DB does is they took that and because Cosmos DB is distributed, they use that as they leverage the distribution to offer different types of consistencies. So for instance, when you write to a strong database, a strongly consistent database, and you try to read it, you can read or write immediately. Otherwise, it will throw a failure condition. In an eventually consistent database, when you write to it and you try to read it, it may have some stale data in it. A good example of this would be Google Analytics, right? Google Analytics, it does not show your latest data. Like if you look at it and say, oh, show me the usage for the last minute, it won't show that. It's going to show you the past day. So that's kind of an example, not in a read-write way, but more of like how lag type of mechanism. So that is more eventually consistent. So what Cosmos DB is saying is that when I try to read my write, I can do this. I can create a strongly consistent instance, and that will only be restricted to one region. So if I create a Cosmos DB instance that's strongly consistent, I cannot make multi-region global distribution type systems. But I can read my writes, and that's guaranteed. Now if I start distributing it, when I go to multiple instances, I can start using the sliding scale. So if I want to read my writes within the same region, I would use something called bounded stages. If I want to read my own writes, so for instance, I open a connection, I write to Cosmos DB, and I want to read it, I can do that with session consistency. This is the most commonly used consistency model in Cosmos DB. About 90% of the deployed Cosmos systems actually use session consistency. But let's say I'm writing to the system, I can read my write, but if he is writing to the system, he could not read my writes. He could only read his own writes immediately. Does that make sense? Yes. It's you can start playing around with the consistency models, and that's how it becomes more.
Big thing for you for later.
Oh, awesome! Special day, I guess. So eventual consistency, I mean, the reads and writes are completely out of whack. But it's okay, like if you're doing logging types operations and you don't care about immediate results, you can use eventual consistency. And that, how it works is, because you used eventual consistency, this number could go down from 15 to 5. So you save on your resource usage. So that's how this, so everything is a trade-off in the cloud. And if people don't, yeah, try.
So, if you are using eventual consistency, what is your time frame to getting consistency? Is it?
Can I give a consultant answer, or do you want to read answer? I'll say it depends, but usually it takes a few seconds. But if you're, it also depends on the amount of data. So if you're doing multi-master writes and you're writing to all the different regions, it could take longer than just a few seconds. But usually it takes a few seconds if you're not doing multi-master. I don't know how long it takes with multi-master writes, but I can't imagine it's too much longer. So what I'm trying to say is eventual consistency is not that bad and you actually save. So if you don't care about the order of your reads and writes, and you're okay with the data, your reads lagging your writes by a magnitude, then use eventual consistency. If you deploy multiple regions of Cosmos DB, the SLS guarantee 5 nines, which is pretty good in use of the cloud. Partitioning is one of the most important concepts of Cosmos DBs. Here's how it works. So you have two types of partitioning. You have physical partitioning and logical partitioning. Physical partitioning is when your data is partitioned on disks, and I think per disk you can store like 10 gigabytes of data. So keeping that in mind, your logical partitioning is your application actually using a key to partition your data. So let's say in this instance, you're talking about airports. So we're using the airports code as a logical partition. So it, depending on the data coming in, based on the airport code, it will route it to the proper partition. So you have to make sure that your logical partition is somewhat, let's say you have a volume of data coming in, right? Like you have billions of records coming in per second. So you want to make sure that not all your data is going into one partition. So that's where it becomes really important. Now keep in mind that because you're doing so what this says is that when you have billions of records coming in, I'm using a logical partitioning to spread that out. Keep in mind that later when you do a query, you may not want to query based on the airport. You may want to put query on a different type. Yeah. So that is when you use this feature called change feed, because change feed at this point when it comes in and it stores, you can store it to a different instance that partitioned differently. So, so at that point, you can go and run a query using the other partition. And what that does is, because the partition is supposed to be in physical proximity, your queries run much faster. If you don't use a partitioning key, your queries will be foobarred. So just keep that in mind. Partitioning for reads and partition. So you might want to start thinking of concepts like CQRS for when you use Cosmos DB. So partitioning is one of the most important concepts while using it. How am I doing on time?
10 minutes.
10 minutes, all right, cool. That's more than time. I've talked about global distribution, multi-master. Okay, to me, one of the biggest advantages of Cosmos, NoSQL database as a service, whether you're talking about Cosmos or DynamoDB or whatever it is that you are saving on things. Okay, so let's say you have on-premises or on virtual machines versus as a service. So the individual costs seem high, but you're saving. Let's take on-premise. You're saving on things like having to set up a data center, having to configure global distribution, hiring people to maintain the data center. So that's a lot of CapEx cost. So there's CapEx versus OpEx that they talk about in business. So a lot of CapEx cost when you do that. So you're saving on that over time. So it's called the total cost of non-ownership. Basically, I don't own anything. I'm trusting that these providers are gonna not mess up my data, and I'm willing to live with that, and that's how I save money. So that's basically that's what it comes to. Now, the individual costs may seem slightly high, but when you look at it from a business perspective, you're really saving a lot of money. So that would be one of my number one arguments for using a NoSQL database as a service, and Cosmos falls under that. There are other ones also.
Which one is the Azure Document DB? Is that the
That's
Cosmos?
that used to be called Cosmos DB.
Okay.
This is from a sorry, Cosmos DB started as Azure Document DB. Now, the funny thing is, they became Cosmos, and then Amazon adopted that name. So now Amazon Document DB. So I started out writing, I started out doing stuff in Azure Cosmos DB 4 years back. So now I get a call from recruiters saying, hey, do you know Amazon Document DB? Because it seems like you have 4 years of experience in that. No, it just came out last month. So LinkedIn for you. This is what a Cosmos DB structure looks like. You create an account in the Azure portal, and then you create something called databases. So this is a NoSQL database. Keep in mind, there are no tables, no rows, nothing like that. Everything is basically stored as JSON documents. So container, so you can create accounts. And the accounts, what they do is they give you a URL and a key to connect to that URL. Databases, you can use this to configure permissions, or you can use this to group containers. Up to this point, it's free on Azure. When you start creating containers is when they ask you what level of performance do you want to configure for this container. And that's when you start getting charged. So let's say you say I want 400 RUs, $25 a month. And that's when this is where you start incurring charges on Azure. So if you're creating Cosmos instances on Azure, make sure you delete your containers. You don't have to delete your accounts and databases. And this container is where your data is stored, whether it's if it's a document database, it's called collection. Otherwise, you have table or graph and so on. The containers also have store procedures, triggers, user-defined functions. We talked about that. You can handle, you can merge data and handle conflicts using these containers, which is beyond the scope of this talk, but just letting you know that's what the structure looks like. And data is stored as items. Now the data could, depending on the type of database, it could be a JSON document, it could be a Azure Azure table storage row, it could be a graph node or edge, and so on. And so the SQL API is the document-oriented database. This is the main, when the people say Cosmos DB, this is what they're talking about, JSON document storage. Unless they say, oh, it's Cosmos DB Mongo API, in which case they're probably talking about something else. This supports SQL-like queries, so you can write link-style queries on this to query it. This uses the Mongo wire protocol, so Cosmos can store Mongo data. And it uses the Mongo wire protocol, which means that if your systems write to a MongoDB and you want to migrate to Cosmos DB, you can simply point it to the Cosmos DB API and it will work. And there's some complexities in that, but for the larger part it will work. So what I would recommend is if you're doing that, look for the Mongo wire protocol, which the one that Cosmos DB supports, whether your MongoDB instance is the same. If it falls within the same ones, you can probably just point it to a Cosmos instance and it will work. Table storage, this is the Azure table storage for the premium version. It's not in preview, it's now general availability. This is one of my favorite types of data storages. It's called graph storage, and you can really add different types of, there's no restriction on what type of objects you can add and what type of relationships you can set. So people say that NoSQL databases are non-relational, and that is not true. And NoSQL databases decide to handle relationships like this one, they're super relational. So for instance, if you try to create these relationships in a regular SQL database, it would be a nightmare, like trying to configure all these relationships. You'd either have to add thousands of columns and leave some of them as null, or you can add join tables in weird ways. In this, all you have to do is draw a node from, or draw an edge from one node to another. So this is a node, this is an edge, and so in this instance, let's say James lives with Mary, and so he's living at her place, but he owns a car, so she's driving his car. It's already becoming complicated relationships. So you can start to address that with these type of databases. And finally, Cosmos DB also supports storing Cassandra data. The difference between a regular table and a Cassandra table is that a regular table, when it stores the data, it tries to store rows of data, like different types of rows of data, in proximity to physical proximity to each other on the disk. In Cassandra type, in Cassandra or other column family databases, when it stores data, it stores columns of data within the same physical proximity. So let's say you have like visits to a website or something like that. So, or hit counter or something like that. So let's say you want to add up all your hit counters. You can store that column gets stored on the same or same disk or physical proximity. So when you're doing aggregations, it is really fast. So that is why that's what the use case of Cassandra type storage. I'll quickly go through this, but I'll also upload slides. I'm still doing good on time, at 3:45. So I'll try to finish this in 5 minutes instead of 10. So to run Cosmos DB locally, you need something called a Cosmos DB emulator. So if you search for Cosmos DB emulator, you download it and store it. It's Windows only, and it only supports SQL and Mongo APIs. I think I've not tried it with 2019, so don't beat me up. It doesn't work. I'm sure Visual Studio Code, if you run it on Windows machine, it will work fine. So it works with .NET Framework and Core. So when you install it, it actually contains sample projects you can download and run. And this is what it looks like. When you install it and it runs, it only runs on Windows. Even the containers that they have, Docker containers, it's Windows containers. So you cannot run the Cosmos DB emulator on non-Windows machine. At least not currently, not that I know of, unless they changed it in the past month. So if you're connecting to Cosmos instance locally, the primary connection string will allow you to do SQL API operations. There's also a Mongo connection string. So you can create both SQL and Mongo APIs locally, and this is your URL, localhost 8081. When you download the sample projects, it's a simple ASP.NET MVC type project. The NuGet package that you'll be using is called DocumentDB. So if you see this name DocumentDB, remember that this guy gave this talk when he explained the history of Cosmos DB and how you see DocumentDB in the libraries. This is why you see it, because it used to be called that. So you can add the endpoint, the authorization key, and a couple of things like the database. And remember the hierarchy we talked about? So this is what the first two are what you get from your account. The next is the database. The next is the collection that stores the actual data. So this is like a MVC app, and to create a sync action result. And it uses the repository pattern. And this is your model. You can see that it's simple fields, and then you use the JSON property. So obviously you need the Newtonsoft.json library that every other project in the world needs. Without that, it's not going to work. So your repository, use the repository pattern in this particular instance. You're free to use whatever you want, but this is what the samples have, and this is what they recommend. So pay particular attention to this document client. That comes from the NuGet package. Once you install that NuGet package, you should be able to get the document client. Once you get the document client, you can configure it using the endpoint and the authorization key. So the account variables are what you can use to configure the client. Once this initialize method, make sure you run it whenever your application starts up, MVC application. Otherwise, you can, if you're doing a console type application, you have to use a different type. But try to make it, I think it's singleton pattern is what it's called. Try to not recreate it all the time, but create it once and use it. Especially in Azure functions, if you see a lot of Azure functions code where they interact with Cosmos DB, they recommend a singleton. So generally use defensive techniques. So this is it's hard to see, but this is where it creates the database. So what it does is using the client object that we created, it says create async database. If the database does not exist, then it creates. So it's kind of a defensive programming, and whenever you're programming in the cloud, you apply defensive techniques to make sure that your resource exists before you try to write to it. This will be further enhanced when you do CI/CD pipelines. Create collection, same thing. Using the client, document client, it tries to see if the collection exists. If it does not, then it creates it. And when you create the client, you will see that over here is where it says 1000. That is the 1000 RUs or the performance level that you're configuring. So doing actual work, simply using the client. So the client is kind of like a all encompassing. It's like a super master key type thing, which you can use to do different operations. So using the client, you can say that I want to create a document. And when you create a document, what you do is you pass the database ID, collection ID, and that returns the URI for the collection. And then you say that I'm going to pass my model. So in an MVC model, you can pass it directly into it. And say create this, and it will create it. So the advantage of doing this type of using this is that there's no object relational models. You can I can take an object of class person, and I can take a car, and I can store it in the same collection, and it is my application that handles the storage and retrieval. There's no ORM. So the overhead of using ORMs is completely bypassed using this. But that puts the onus on you of having to do the storage. And let's say you have a class and of type person, and then you change the structure of that class, and you're not able to retrieve your data because you changed the structure. That kind of falls back on you because you're not using an ORM. Any questions so far? If you are into DevOps, which I highly recommend you should, you can actually run the Cosmos DB emulator on your DevOps pipeline by installing the Cosmos DB emulator. I think it's still in public preview. I could be mistaken. When I took the screenshot, there was like one install. Now it's far more than that. So as you can see, it's really neat. So closing thoughts on Cosmos DB. Basically, get started. What I would say is, instead of saying I'm gonna convert my whole system to Cosmos DB, don't, again, like Justin was talking about this earlier, don't boil the ocean. Start small. Start with a small component of your system. Try to use Cosmos DB. Again, the use cases depend on the type of data and everything else. Read up on the basics of NoSQL and make sure you're using it for the right use case. Don't use it because Cosmos DB is cool. I've seen many people do this.
That's one of the problems.
Yeah, that's a huge problem. I work for a client, and I would not name the client, but they are a big soda company. You can take guesses. They had terabytes of data, hundreds of terabytes of data, and the problem was that they had not read up on the partitioning of Cosmos DB correctly. So everything was stored in the incorrect partitions, which means when they ran queries, it was taking minutes because it's hundreds of terabytes. And so they were cranking up the RUs, which means that it gets really expensive. So read up the basics before you do it. I cannot stress this enough, otherwise you'll end up spending a lot of money and probably get fired. read that up. Serious about this. But if you do it right, then you're the hero. So, polyglot data persistence, which means you can store JSON documents, graphs, table storage, everything else. And always, when someone says Cosmos DB is expensive, if you cannot explain the value, I would start right there and figure out what the value is, whether it's speed of retrieval, whether it's global distribution, or whether it's the versatility, the type of data it stores, all of the above. I would say the total cost of ownership is also a huge thing. If you're spinning up a Mongo cluster and trying to, and as virtual machines and trying to maintain that, it's a nightmare. Ask me. So all of those fall on the value side of things. So if they say it's expensive, explain the value part of it. And that is it. I will upload this talk, and then I'll upload this talk to GitHub and the code samples, and hopefully you'll get to try Cosmos DB. Thank you. Okay, so what we'll do now is, let me stop the streaming first. So, so I have a bunch of prizes. So you stuck with me for this long. Give me, 10, 15 more minutes, and then we'll be done with this. So I have with me JetBrains licenses, Obstilities, Kill Me Up license. So as we call your name, if you don't pick up any for your friend that's not here, make sure you get it for yourself. It's an honor system, so please keep that in mind. There's plenty of JetBrains. Now, one thing I would do is keep an eye on the date. So this one says June 1st, and this one says April 30th. So if it's April 30th, then and you get a JetBrains license, please activate it immediately. Don't wait until June 1st and tell me that it's not activating. So as we call your name, just come get it. And what I'll do is I'll use a random number. You got it? Okay.
I got a bunch of random.
Okay, go on.
All right, first one is 27.
27 is Kevin Miller. No? All right, no.
The next one is 7.
7 is Miguel Iglesias. Miguel? No?
All right.
Just keep going.
Number 35.
35 is Kyle Padilla.
23.
23 is Pallav. Actually gave him a hand. He's the first person in the prizes who actually is here.
Let me see. 34.
34 is Eric Morales.
Okay. Next one is 18.
18 is Clay Cypher. Yeah, get it. Come grab whichever one you want. It's a first come, first serve.
I don't know what the cutoff goes is all about.
Next one is 16.
16 is Mario Quintilla.
6.
6 is Marco. There we go.
24.
24. Joel Rosich. Joel.
15.
Abdul Kumar.
I don't know which one. What are they?
2.
I'll get this.
Okay.
What is this?
22.
22 is Daily? 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 D-E-I-L-Y? 11, Vishal. Sorry, is
I have no idea what that is.
Elio?
Sorry.
Elio? Yes.
What's rep dev? What's rep dev?
It's a debugging tool that allows you to do time-based debugging. So it's really cool. You should try that. If you already have a JetBrains, I would recommend it.
And this is what? I don't want to get one.
Make sure you activate it immediately. Yeah.
Thanks, Mario.
Chandir?
Chandira.
Chandir Mohan? Chandira, okay.
Next 13.
Nothing else, Hari? Not me? No, this is Hari first.
36.
36. See what?
Shiva. Oh.
8.
8 is Michael Godfrey. You know, he's not.
9.
Lavar Cooper.
25.
Jesiah. Not this Kasar. She's not here. This is
29.
Ken Tucker.
Hey.
We have 2 more.
Yeah.
To get rid of the big parts.
Yeah. Now the next one's 32.
32 is Taylor.
About 12.
Richard. Rossi. Sorry, I'm probably butchering it. You get a prize for that.
It's Italian. It's a lot less than 30.
31.
30. Hunter. And the last one is the big one. Hopefully you stayed here.
All right. 19.
Jeremiah.